Right, next we're going to look at water treatment. A lot of this you've covered from junior cycle, but it's still worth reviewing. It does come up. So, our water that we consume needs to fulfill a certain brief. It needs to look good. It needs to not smell. It needs to be safe to drink, and it needs to be fluoridated. Obviously enough, when it comes out of a river or a lake, it does not fulfill those requirements. So it goes through a series of different procedures that come under the heading of water treatment. So these are outlined in the picture that we have here, but we'll go into a little more detail on the next slide. So the first stage of water treatment is called screening. The water that's just come out of your river or your lake is passed through a wire mesh, and that's just to get rid of large debris. If you're in Limerick City, that might be a trolley, or if you're somewhere else, it might be a plastic bag. Once it has been screened, it is treated with flocculating agents. An example being aluminium sulfate. Now, to flocculate means to cluster together or to clump together. Some of you might know that from ag science. When you add your flocculating agent to the water, you cause all the tiny little particles that are suspended in the water there, so they're just floating around. They're not dissolved, they're just floating around in the water, these tiny little particles. You cause them to clump together, and that will help you remove them in the next stage, which is sedimentation. So sediment is a kind of a residue or a leftover. In this phase of the water treatment, the water is passed into what's called a settlement tank. It flows in at the bottom and it rises slowly upwards. And as it does so, those heavier particles that have flocked together settle out at the bottom of the tank. So the water then that gets up to the top of that tank will flow out over the top of it or overflow, and it'll be nice clear water. Now, the next step then is to get rid of even the tiniest little particles that are in there, and that's achieved by filtration. So the water at the top of the settlement tank is passed over into some filter beds, and these are beds full of sand of various different sizes, from finer down to coarse, and even some gravel in there. And they act like a filter, and that's where it gets the name filtration. And that will get rid of even the tiniest of those suspended particles that are in the water. Now, at this stage, you have really clear looking, clean looking water, but you might not have gotten rid of any of the bacteria in the water, for instance. So the next stage is chlorination. Chlorination is the addition of chlorine. Chlorine gas is added at a rate of 0.5 parts per million, and that's fairly strictly controlled, because if you put in too much chlorine, it'll leave a very bad taste and smell on the water, and that concentration of chlorine gas is enough to kill off any microorganisms that are in that water. Then we move on to fluoridation. In Ireland, our water is fluoridated by the addition of either sodium fluoride or hexafluorosilicic acid. So either of those fluorine compounds added to the water in a concentration of 1 part per million will prevent tooth decay. They do that by strengthening the enamel of the teeth. Once again, you've got to be careful though not to put in too much. If you do, you get a characteristic kind of a staining on the teeth. There's a picture of it, I think, in your book, and that's called fluorosis. There has been a lot of talk about fluoridation in the last number of years, maybe for the last decade even, as some people are worried that the fluoride concentration in our water could be a contributor to cancer. So you get campaigns every so often to stop the addition of fluoride to water. That's not likely to come up in the course though. And then the final stage is pH adjustment. So you're aiming here for a pH of 7.2. If it was too acidic, you would get corrosion of your water pipes. So you'd add calcium hydroxide in there. Now, you've got to be careful because if you add in too much calcium hydroxide, that'll affect the taste. It'll leave a taste on the water. If it's too basic, on the other hand, you'd add some dilute sulfuric acid. And again, you don't want to add too much dilute sulfuric acid or you can cause corrosion. And that is your water treatment in a nutshell. So the next thing that we're going to look at then is water analysis. Now there's an experiment 17, it's one of the mandatory experiments, and it's actually 3 experiments in one. They're nice and easy experiments, and I've put a link into the content library so that you can look up one of Declan's students performing these experiments. They're fairly straightforward. So the first one is to look at the total suspended solids, and this is measured in parts per million, the total suspended solids. Now, suspended, as I explained to you earlier, means it's not actually, these solids are not dissolved, they're just tiny particles that are floating around in the water. How do we get rid of insoluble particles? We filter. And how can we measure that? Well, we basically weigh the filter paper at the start, so get the mass of the filter paper at the start, then put a known volume, in this case a litre of the water, through that filter paper. You'll see that this is a Buchner filtration here, a Buchner funnel, and you filter your litre of water, and as the water goes through, it'll leave the little residue on the filter paper. Then you dry the filter paper. You can do that in an oven or you can just leave it to air dry, and then you find the new mass. And then you subtract the earlier mass, that was the dry filter paper, from the mass at the end, and that's the filter paper with the suspended solids, those solids that were insoluble in water on it, the ones that were filtered out on it. That will give you the mass of suspended solids in that litre of water, and I'll show you a little calculation in a few minutes as to how you change that into parts per million. Okay, now you also keep the water that's down here in your conical flask for the second part of this experiment. And the second part of this experiment is to look at the total dissolved solids. Okay, so far we have removed the suspended solids. So the other solids that are in there are the dissolved solids. So these are in solution, you can't see them, and they're not going to be filtered out by the filtration that you did earlier. So how can we work out the level of dissolved solids? Well, again, the procedure is to just get rid of the dissolved solids and then check your mass before and after. So you take the litre of filtered water, that's the filtered water here that you had from part A of the experiment, and you heat it on a water plate until it's dry. Now it's very gentle heating that you do until it is dry, and you find the mass of that beaker. Obviously before you start you found the mass of the dry beaker. Then you put in your litre of water, you heat it to drive off the water, and you'll be left with a residue all over the inside of that beaker, and that's the dissolved solids that were in the water. And then if you allow that to cool and find the new mass, and again you do a subtraction of the original mass of the beaker from the mass of the beaker now with the dissolved solids on it, and that will give you the mass of dissolved solids. And again, you are going to express that in parts per million for your sample of water. So the third part of the experiment then is to find the pH, and that's really straightforward. The pH, sorry, I shouldn't have gone on there. The pH is just found by putting in a pH probe and using a data logger to read off the pH. That's detailed down here at the bottom of the next slide. Put in a pH sensor and then you'll read it off the display on the computer screen. So those are three different measures of your water quality. So your total suspended solids, that's the one that you do by filtration. Then total dissolved solids, you do that by evaporating off the water. And then the pH, which you do with your pH sensor. Right, so now we're going to look at a quick calculation using a specimen set of results from that experiment. Now, a student filled 500 centimetres cubed of water and found that the mass of the filter paper after drying had increased by 0.68 grams. Then 100 centimetres cubed of that filtered water were evaporated to dryness in a beaker, and it was found that the mass of the beaker had increased by 0.13 grams. So effectively this student is doing part A and part B of the experiment that I've just talked about. So what is the amount of suspended solids, it's asking first of all, and also the amount of dissolved solids in the water, expressed as parts per million. Now the only bit of this that really will cast us a thought at all is how to get to parts per million. You might remember that I said when I showed you the last calculation that parts per million means milligrams per litre. So all we have to do is change our units, really. So we were told here that when the student filtered 500 centimetres cubed, the mass of that filter paper went up by 0.68 grams. So that means that there was 0.68 grams of our suspended solids, the ones that can be removed by filtering, in 500 centimetres cubed. Now we want to change that from grams in 500 to milligrams per litre. So to get from 500 to a litre, you just multiply your 0.68 by 2, and that will give you your milligrams per litre, which is 1.36 grams per litre. And now in order to change from grams to milligrams, we multiply our 1.36 by 1,000, and that will give me 1360 milligrams per litre, or that is a total suspended solids of 1360 parts per million. Okay, now let's look at the second part of the experiment. The student then took 100 centimetres cubed of the filtered water, 100 centimetres cubed, and evaporated it to dryness. And then that beaker had a little residue left on it, and that was the dissolved solids that were left as that residue. The student had obviously got the mass of the beaker at the start and got the mass of the beaker at the end and found that it went up by 0.13 grams. So what does that tell us? It tells us that 0.13 grams of our dissolved solids were in 100 centimetres cubed of the water. Okay. Now we want to change that from grams per 100 centimetres cubed into grams per litre, and then milligrams per litre again, so that we have it in parts per million, because milligrams per litre are the same as parts per million. So we take our 0.13 grams there, and we multiply it by 10 to go from 100 centimetres cubed to a litre, and that's going to give me 1.3 grams per litre. And then if we have it in grams per litre, we just multiply that by 1,000 again to get 1,300 milligrams per litre. Or what does that tell us? Overall, our total dissolved solids, remember we're talking about the dissolved solids this time, are equal to 1300 parts per million. And that's your worked example from those two experiments. Obviously there's no calculation to be done on the pH, it's just to be read off a screen.